So 13.3, we are going to start with 13.3 surface area volume. In my previous video, I had already explained to you 13.1 and 13.2. Okay, so here is the question. The metallic sphere of radius 4.2 is melted and recast into a shape of a cylinder of radius 6. Find the height of the cylinder, right? So this is a very simple question. The question says that there is a metallic sphere and the sphere is melted. Now please remember, when you melt one figure to the other, the volume remains the same. The volume remains the same. So what are we going to do? This is a metallic sphere of radius 4.2. The radius is 4.2. It is melted into a cylinder of radius 6. So cylinder is radius 6. The question is find out the height of the cylinder. So what we need to do is just equate the volume. So I can say V1 is equal to V2. So 4 by 3 pi r cube is equal to pi r square h. 4 by 3 pi r cube is equal to pi r square h. So what we are going to do is equate the volumes. V1 is V2, 4 by 3 pi r cube is equal to pi r square h. That is the equating the volumes. 4 by 3 pi r cube is equal to pi r square h. Now the radius is different, so I have assumed small r and capital R. Pi we can cancel. So this will be 4 by 3 into 4.2 into 4.2 into 4.2 is equal to r square into h. Okay, r square into h. So the radius is 6 for the cylinder. So this is 6 into 6, and we need to find out the height of the cylinder. So height of the cylinder is unknown. So 3 I can cancel here. This is 1.4, right? 1.4 into 4, that will be 5.6 into 4.2 into 4.2 divided by 6 into 6 will give me the value of h. So this is going to be 0.7. This is going to be 0.7. So this will be 5.6 multiplied by 0.49. That will be the height of the cylinder, right? So we can multiply this 0.49 into 5.6. I multiply 9 6 are 54. 24. So this is 294, 9 5 are 45, 5 4, 5 was 20, 24. So 4, 9 plus 5, 14, 4, 1, 6, 7. So we get 2.744 centimeter as the height of the cylinder. So 2.744 will be the height of the cylinder. So that's how we get this answer, 2.744. Okay, we are equating the volume of the sphere and equating it to the volume of the cylinder pi r square h. Of course, the formulas you have to know. Next one, metallic spheres of radius 6, 8 and 10 are melted to form a single sphere. So we have 3 spheres, 6, 8 and 10, and we are melting it to form one big sphere. So what will be the formula here? We will say 4 by 3 pi r1 cube plus r2 cube plus r3 cube. The 3 cubes together are melted will be equal to the volume of the big sphere, 4 by 3 pi r cube, right? So we have 3 spheres melted, all these are melted, and you are getting one big sphere. So 4 by 3 pi r1 cube plus 4 by 3 pi r2 cube plus 4 by 3 pi r cube is equal to 4 by 3 pi r cube. So 4 by 3 pi I can directly cancel. So we are left with r1 cube plus r2 cube plus r3 cube. So what is r1 cube? 6 cube plus r2 cube, that is 8 cube, plus 10 cube is equal to r cube, because the 4 by 3 pi is getting cancelled. So this is going to be 216 plus 512 plus 1000 is equal to r cube. So r cube will be 1728. When I add these three, I'll get 1728. So radius will be cube root of 1728. So cube root of 1728 is going to be 12. If you don't know how to find cube roots, you need to do this by prime factorization, make groups of 3, and just like you did square roots when we make groups of 2, here we have to make groups of 3, and then when you multiply that, you are going to get 12. So we can say radius is 12 centimeter. Okay, so I hope you understood the logic that when you melt, the volumes are going to remain the same. So that's question number 2 for you. Then we go further to question number 3. So what does question number 3 say? Question number 3 says, a 20-meter deep well with diameter 7 is dug and the earth from the digging is evenly spread to form a platform 22 by 14. So what is happening is that you are digging a well and the mud from this well you are taking out and putting in a rectangular piece of land, and we have to find out what will be the height of this land. So what is the mud taken out? That is going to be pi r square h. Diameter is 7. So using pi r square h, we can find out the volume of the mud. So volume of the earth taken out is pi r square h. Okay. So we have got this. And where are you putting it? You are putting it in this field. The length and breadth is given to you 22, 14. We have to find out the height. So please note that height will always be equal to the volume of mud taken out divided by the area over which it is spread. So here we have calculated the volume of mud as 770. And where are you putting it? You are putting it in a platform. The area of the platform is L into B. So that's going to be 22 into 14, right? So 22 into 14. So that's why we are dividing this by 22, 14. Can cancel by 11, 11 2, 11 70, 14 5 times. So we are going to get 5 upon 2 and 5 upon 2 we get 2.5. So height of the platform will be 2.5, right? So basically what's happening, we are equating the volumes. The volume of the mud here will be equal to the volume of the mud here because the same mud is being transferred. You're not putting extra. So LBH is equal to pi r square h basically. So that's what we are getting, this volume by area. Okay, that's question number 3. So we move on ahead to question number 4 now. So question number 4 says, okay, that's question number 4. A well of diameter 3 meter is dug. 14 meter, diameter is 3. So radius is going to be half of that, 3 by 2. Radius is 3 by 2. Height is 14. So you are digging a well and then you are spreading it all around it to a circular ring to form the width of which is given 4 meter to form an embankment. Okay, so what is the question is, unlike the previous question where the mud was taken out from the cylinder and you are putting it in a rectangular piece of land, here you are putting the mud all around it. So this is the well. And what is happening? This is the ground level. Now people will fall down into the well. So in order to prevent that, they form an embankment. So you're putting the mud all around it. So gradually when you put the mud from the well here, what will happen? This is going to rise. And the question is, what will be the height of this embankment? You've seen wells, no, in villages and all. There will be an embankment. It will be of a certain height, not at ground level. So this is the embankment, which is to protect the people from falling inside, especially kids and all, they fall. No? So here, this is the question. So question is, what will be the height of this? Again, height will be volume upon area. So we'll have to first find out the volume of the mud that is taken out. That is pi r square h. So pi r square h, I'm finding out the volume. And where are you putting it? You are putting in the ring. So what is the area of a ring? Area of a ring is outer circle minus inner circle. So we will take pi common, we get r square minus r square. So we get 1.5 was the inner diameter and then the width of the embankment is 4. So 4 plus 1.5, you are going to get the outer radius as 5.5. So that's why we are taking pi r square minus r square. So capital R, we are taking 5.5 minus 1.5 square. So a square minus b square, you can apply a plus b, a minus b formula. So a plus b, 5.5 plus 1.5, you will get 7, and 5.5 minus 1.5, you will get 4. So we get pi into 7 into 4. I'm not cancelling pi because we know that height is volume upon area. So when I divide this, the pi is going to get cancelled, right? So we are going to get 9 into 14 and 4 into 7 into 4. I can cancel this 2. This is going to be 7. 7 and 7 gets cancelled. So what are we left with? We are left with 9 upon 8. And when we divide 9 upon 8, we will get 1.125. So that will be the height of the embankment. So after question number 4, we go to the next question, that is question number 5. Right. So question number 5 is a container is shaped like a cylinder having diameter 12 and height is 15 and it is filled with ice cream. Right? It is filled with ice cream. So it's a huge cylinder filled with ice cream. Diameter is 12, so radius is going to be 6. Height is going to be 15. And what are you doing? All the ice creams are going to be filled in conical. The shape of the ice cream is cones with a hemisphere. Now this is tricky here. It's not a cone, it's a cone with a hemisphere. Softy jaise hota hai na. So you will have those cones and then you have extra scoop of ice cream on top. So this is what the question is. Diameter is 6, so radius is going to be 3. And what is happening? The height of this is given as 12. The cone's height is given 12. So how many ka question aata hai, find the number of cones that can be filled. So number can be found by taking out the volume of the cylinder and dividing by the volume of one ice cream cone. So what is the volume of the cylinder? Pi r square h. Volume of the ice cream cone is pi r square h. So pi into 6 into 6 into 15. Okay, so that's going to be the volume of the cylinder. And what will be the volume of the ice cream cone? It will be 2 by 3 pi r cube. That is the volume of the hemisphere plus the volume of the conical part, that is 1 by 3 pi r square h. So 2 by 3 pi r cube plus 1 by 3 pi r square h. So when I calculate this, 2 by 3 pi r cube plus 1 by 3 pi r square h, I'm going to get 54 pi. I'm going to leave it as pi because later on I know that I can cancel the pi, because as I told you, number of cones that will be possible will be the volume of the cylinder upon volume of one ice cream cone. So this is going to be 36 into 15 pi divided by 54 pi. So pi will get cancelled. Okay, we can cancel out pi here. And I can cancel this by 9 now. 9 4s are 9 6 by 3 3 5 3 2 then 2. So 5 into 2, how many cones will be possible? We'll get 10 cones. We can make 10 ice cream cones out of this total ice cream that was present. Then moving on to question number 6. Moving on to question 6. Again, how many silver coins? 1.75 cm in diameter. Thickness 2 millimeter must be melted to form a cuboid. Okay, so first of all, let's understand this is a silver coin. Silver coin, what will be the shape of the coin? So shape of the coin will be like this, and it will have a small height. Coin will have a small height. So actually it's a small cylinder. So 1.75 centimeter is the diameter. So radius is going to be 1.75 upon 2. Okay. And this is 1.75 by 2. So what we can do is remove the decimal. 2 decimal we will remove. So it will become 175 by 200. So 175 by 200 we can cancel by 25. We will get 7 upon 8. So radius will be 7 upon 8. It's easier to calculate. So now how many has to be melted? So the diameter is given. Okay, thickness is given 2 millimeter. Now this thickness of the coin is actually the height of the coin. Thickness of the coin will be the height of the coin. So 2 millimeter will be how much? 0.2 centimeter. So height we can take as 0.2 centimeter or 2 by 10 centimeter, up to you. So what will be the volume of this coin? Volume of the coin will be pi r square h. So that's going to be 22 by 7 into 7 by 8 into 7 by 8 into 0.2. So I can cancel this here, and 2 goes 11, 2 goes 4 times. And this will be 77 into 0.2 divided by 4 into 8. And what will be the volume of the cuboid? Volume of the cuboid will be LBH. Volume of the cuboid will be L into B into H. So what will be the number of silver coins? Number of silver coins will be the volume that we have got here, 77 into 0.2 into 4 into 8, that can be written as 32. This is the volume of one coin. we are going to divide the total volume of the cuboid, that is 5.5 into 10 into 3.5. So volume of the cuboid divided by volume of one coin will give you the number of coins. Number of coins will be this. So this I can easily calculate, because 5.5 into 10, I'm going to get 55 into 3.5 divided by 77 into 0.5, and this 32 that you find, that I can transfer on top. So this will be into 32. Now this decimal, I can remove one decimal from numerator and one decimal from the denominator. Now 11, 5, 11, 7. 7 goes 5 times. So this 5 and this 5 gets cancelled, and we are going to get the number of coins. So 5 and 5 has got cancelled, yeah. So final answer, when you do the calculations here, you should get number of coins is equal to 400. Okay, you can do the calculations. You should get 400 coins. Okay, so you can work that volume of the cuboid LBH divided by volume of one coin. By the method I told you, that will be simpler instead of doing all this. So we can easily calculate the number of coins. Then we go to question number 7. Question number 7. A cylindrical bucket is 32 centimeter high and radius of the base is 18, filled with sand, and it is emptied on the ground and a conical heap is formed. So the question says there was a cylindrical bucket, and what has happened, this was filled with mud, and when you put the mud on the ground, it formed a conical heap. So the volume is going to be same. So pi r square h will be equal to 1 by 3 pi r square h. The volumes are equated. So pi, I am letting it as it is because I can cancel pi from both sides. So pi r square h, radius is 18. So 18 square into height is 32. So pi r square h is equal to 1 by 3 pi r square. Radius we don't know. The height of the cone is given 24. Right? So what will happen? The pi is getting cancelled here. 3 goes 8 times. So r square will be 18 into 18 into 32 divided by 8. Right? So this I can cancel. 2 goes 4 times. 2 goes 16 times. Then 2. This is 9. Again 9. Right? So here when we calculate this, we should be able to get the value of r. This is r. First you will get r square, and then you will have to calculate that. So let me show this on the board for you. So as I said, the pi r square h will be equal to 1 by 3 pi r square h. I am putting this, so pi is getting cancelled. And what is happening? The height of the bucket is 32, radius of the is 18. Okay, so 18 into 18 into 32 is equal to 1 by 3 r square. And what was the height of the heap? Height of the heap was 24. So I told you this will cancel. So r square will be 18 into 18 into 32 divided by 8. Right? So this now is r square value. So I'm cancelling by 2. Okay, this I get, and here I can cancel this 4 times. So r square is 18 into 18 into 4. I can write as 2 into 2. So radius will be square root of 18 into 18 into 2 into 2. Now 18 and 2 we can make groups. So this is going to be 18 into 2, and we get the radius as 36 centimeters. So this is the working for that. So we'll get 36 centimeters as the radius. Right. So once we get the radius, then slant height. What is the formula for slant height? L square is equal to h square plus r square. We can find out that slant height because now we know the radius is 36, and we have to find out the slant height. So radius we have already calculated, now 36. So 36 square plus 24 square. So L square is h square plus r square. So 24 is the height already given. Radius we have found out. So we will calculate this. We should get 12 root 13. Okay, 12 root 13. Okay, because 36 square and 24 square, when you add that, you will not get a perfect root. So we'll have to simplify it and write it as 12 root 13. Okay. Then we go to question number 8. Water in a canal 6 meter wide and 1.5 meter deep is flowing with a speed of 10 km per hour. How much area will it irrigate in 30 minutes if 8 centimeter of standing water is required? So the shape of the canal is a cuboid. The width is given, breadth is given 6, height is given 1.5, and water is flowing at 10 km per hour. Now this is very important. In physics, you have done this, that speed is distance upon time. So this is the speed. So distance is 10 km, time is 1 hour. So 10 km, when I convert into meter, that is going to be 10,000 meters. So first I am going to find out the volume of water that is going to come out in 1 hour. So volume is LBH. So that will be 10,000 multiplied by the breadth is 6 into height is 1.5. So this is going to be 90,000 meter cube of water that is going to come out in time is what? 1 hour. This is in 1 hour. But our question is how much will it irrigate in 30 minutes? Now 30 minutes is half an hour. So that is why I have to divide 90,000, that is full 1 hour, divided by 2, then I am getting 45,000 meter cube. This is what is going to happen in 30 minutes. So 45,000 is the volume of water that is coming out through the canal in 30 minutes. Now what is happening? This water is going, and the question is how much of water, standing water, how much area will it irrigate in 30 minutes if 8 centimeter of standing water is required? Now what is happening? This 45,000 meter cube of water that is released in 30 minutes is going into a field. And the question is, what is the area of this field? If 8 centimeter of standing water is required, 8 centimeter standing water is required means this is the height. Okay, so 8 by 100 meters if I want to convert centimeter into meter. So I know that volume should remain same because the water that is coming out is going here. So there is no loss of water. Every drop of water that is being released from the canal is going here. So I can say V1 is equal to V2. So what is the equation? 45,000 is equal to L into B into H. So 45,000 is equal to L into B is not given, but I know that L into B is area. So area into 8 upon 100. So I'm going to get 45,000 into 100 divided by 8 as the area. So this will be 8 5s are 40, 8 6s are 48, 20, 8 2s are 16. So we'll get 562,500. This is going to be the area in meter square. Now, this conversion, you can note down that 1 hectare is equal to 10,000 meter square. So I'm going to divide this by 10,000. Okay, this is in meter square. I want to convert this to hectares. So I'll divide by 10,000. This is in meter square. So this I can write as 562,500 divided by 10,000. So divide by 100. So this is 56.25 hectares. 56.25 hectares of land can be irrigated, okay, in 30 minutes if 8 centimeter of water is required. So here they have left the answer in meter square. I think in the textbook they have written in hectares. So it is better that you convert into hectare because more than 10,000 meters square will become 1 hectare. So we normally convert into hectares. So divide by 10,000 and you are going to get this 1 hectare is 10,000 meters square. Divide by 10,000, 56.25 hectares. Right. So we go to the next question, question number 9. Okay, that's the last question. Important question. A farmer connects a pipe of internal diameter 20 from a canal into a cylindrical tank. So what is happening? Water is coming from a pipe. Diameter is 20. So radius is going to be half of that, 10 centimeter. And this water that is coming is flowing into a cylinder. Okay, the dimensions of the cylinder are given here. 10 meter is the diameter. So radius is 5 meter and height is 2 meter. Question is, how much time will the tank take to fill? how much time. So time, you can note down this, time is always equal to volume of vessel by volume of the pipe. Volume of vessel by volume of the pipe. So pipe and vessel both are cylinders, but the heights are different. Okay, so pi r square, I can denote this pi r square h divided by pi r square h. So pi is going to get cancelled. So the vessel is going to have a radius of 5. So that's going to be 5 into 5 into height is 2 divided by r square h. So what is the radius of the pipe? 10 centimeter, 10 by 100 meter, that is 0.1 meter. So you'll have to convert centimeter into meter by dividing by 100. So 10 by 100, 0.1. So 0.1 into 0.1 into what is the length of the pipe? Now, the rate of flow of water is 3 km per hour. 3 km per hour means 3000 meter per hour. So we know that distance is, speed is distance upon time. So distance is what? 3000 meters and time is 1 hour. So this is the distance. Distance is the same as the length. So we can assume the length of the pipe as 3000 meter with respect to 1 hour. Okay. So I am going to substitute that 3000. So 5 into 5 is 25, 25 into 2 is 50, divided by 3000 into 0.1, 300, 300 into 0.1, 30. So 50 by 30 hours, that is 5 by 3 hours. And if I want to convert the hours into minutes, multiply by 60. So we get 5 into 20, 100 minutes. So the vessel is going to get full in 100 minutes. That is approximately, not approximately, exactly 1 hour and 40 minutes. So you can leave the answer as 100 minutes or you can leave it as 1 hour 40 minutes. Both are correct. So how much time is asked now? So 100 minutes or 1 hour 40 minutes. Both are. So the vessel will get full in 1 hour 40 minutes. Then earlier we used to do 13.4. Now the good news is for this year, due to the COVID conditions, 13.4, that is frustum of cone, is deleted. So frustum of cone is not going to be there. That is deleted. So 13.4, you need not do. Right? So you can delete it. The students who are giving the exam in 2021, for them 13.4 is cancelled because this was based on frustum of cones.